So in front of me is a copy of the 2016 Math Exam 2. Well, even if it's from the previous study design, it still contained a lot of relevant and good questions. So let's take a look at the extended response question first. The first question is regarding cosine function, and the amplitude is 2, the center line or equilibrium position is pi. So if you want to find a period and a range of f, you are going to say, okay, period. By the way, the m value here is the coefficient of x. So I'm going to write a half here. And the period is 2 pi over half. That is 4 pi. And then the range of f is equal to c minus a, c plus a. So you are going to get, for example, pi minus 2 and a pi plus 2. Okay, make sure you identify c and a correctly. It's from the equilibrium position going up by 2 units or going down by 2 units. The next thing is state a rule for the derivative function f dash. By the way, if you are defining this function on your CAS calculator, which is like that, f of x is assigned to 2 cosine of half x plus pi. And then you can find shift minus x f of x. So you get a minus sine half x. And the next part just wants the equation of tangent to the graph at x equals to pi. So we might want to type a y equals to, then press menu for 9. And that's f of x, comma, at x equals to pi. So the equation is y equals to 2 pi minus x. Just regarding this derivative function, the question didn't ask for the domain. So you don't have to state the domain, but if you state the domain, you have to make sure you state that as an open interval. So I'm going to say f dash of x is minus sine x on 2, where x is greater than 0, less than 2 pi. Because if you, let's say, define f of x in this fashion, 0 less than or equal to x, less than or equal to pi. And then for derivative, you will see these two values are excluded. Actually, this is 8 pi, okay, 8 pi. So you get a minus sine half x, 0 to 8 pi excluded. Then I'm just writing down the equation of tangent at x equals to pi. The tangent is y equals to 2 pi minus x. And make sure you write down the equation. So the expression needs to have a left-hand side, y equals to. Moving on. Actually, it's one more page. Find the equations of the tangent to the graph that have a gradient of 1. So you are going to equate the derivative function to 1, solve that over this domain, and you should be able to get some x values. What I'm trying to do is I'll solve that equals to 1, x, because in my second definition here, I've included the domain restriction. In the solve command, I don't have to include the domain restriction. So I'll get a 3 pi and a 7 pi. Then what I'm going to do is I'll grab y equals to tangent line fxx, pi, this command, but I'm going to put a curly bracket. That is 3 pi, and 7 pi. Oh, actually, bear with me. It doesn't allow me to do this. So I'm going to say 3 pi and 7 pi. Okay. Just be mindful if you define the function with the domain restriction. Well, I think if you don't include the domain restriction, you may put a curly bracket here, 3 pi, 7 pi. Okay. So you can actually get the two equations. So the first step is to include x equals to 3 pi, x equals to 7 pi. Then add x equals to 3 pi, the tangent, is y1 equals to x minus 2 pi, if I'm not mistaken. At x equals to 7 pi, the tangent is y2 equals to x minus 6 pi. Okay, so the question says find the equations of the tangent. So these two equations. Okay, here I'm going to do some modifications because this matrix mapping notation is no longer in the 23 to 27 math method study design. You might see this kind of thing like the first bit t is r squared mapped to r squared because it's a plane to plane. And then the second part of the equation, they just give you t bracket xy equals to 1 times x minus y. So plus 1 times x minus pi, comma, and ay plus b. Ay plus b. So you get, you say these two expressions representing the new pair of coordinates. What I'm going to do is, first, the rule f dash can be obtained from the rule of f. So you should have, let's say, from which one to which one. The old expression is y equals to f of x. The new expression is, the new equation is y1 equals to f dash of x1. So the old equation will have y equals to 2 cosine half x plus pi. If you are not entirely sure, you can flick back and look at this equation. And the new equation is y1 equals to minus sine x1 divided by 2. In your Cambridge textbook or Jacaranda textbook, etc., they would use y dash and x dash notation to represent the new pair of coordinates. Here, I'm just more comfortable with y1, x1, which means the same thing. The next thing is you need to identify these two equations. Here, from this bit, we should have from the transformation y1 equals to ay plus b, and x1 equals to x minus pi. Once you get these two equations, the normal textbook approach would be rearranging for y and x and substitute into the old equation and isolate to get the new equation, isolate, for example, the y1. But here, if you have the two equations available, you can directly get y1 into here and x1 into here, and still do the reverse mapping. We say sub into equation 2, you will get ay plus b equals to minus sine x minus pi divided by 2. Here, you might recognize x minus pi divided by 2 as an alternative form. But if you have your CAS calculator, I would say, okay, just type in, let's say, minus sine bracket x minus pi divided by 2. It will actually get rid of the minus sign and get you a cosine half x. So this is where you can use your CAS calculator to save you a bit time, other than flicking through your band reference to look for this induction formula or symmetry formula. The next thing is you can rearrange this equation now, because now you can say y equals to 1 over a cosine of x. And then you will get, for example, if you subtract b both sides and divide by a, you say, okay, this is like a minus b over a, right? And then you could see, all right, how about I match this equation with the old equation? So you would say 1 over a equals to 2. This bit, and minus b over a equals to pi. Minus b on a equals to pi. So therefore, your a equals to half. And b equals to minus half pi, okay? something along this line. If you try to verify, you might say, okay, with the A and B values, we can solve y1 equals to 1 over 2y minus pi on 2. Okay, this is the first equation. The second equation is x1 equals to x minus pi, comma xy. And then you type in y equals to f of x. Given that, just bring them down and then solve this equation for y1. Yep, that actually gives you the derivative function, so that is correct. Okay. Lastly, if you look at, let's say, part F, find the values of x from 0 to 8 pi such that fx equals to 2f dash x plus pi. So basically, you can just type in the equation in your CAS calculator and get the solutions, okay? But there were 2 marks. You probably say, okay, 2 lots of cosine half x plus pi equals to 2 lots of f dash. So minus 2 sine half x plus pi. You can actually obtain a simpler equation, say sine over cosine is minus 1, etc., etc. Just say solve for x over 0 to 8 pi. Actually, I would prefer this one be a round bracket because the domain of f dash is round bracket anyway. We say solve 2 cosine of x on 2 equals to minus 2 sine x on 2, comma x, given that 0 less than or equal to x less than or equal to 8 pi. So you get these 4 solutions, okay? X equals to 3 pi on 2, 7 pi on 2, 11 pi on 2, and 15 pi on 2. That is the final answer. All right, we can move on and look at question 2. Question 2 started with cubic function in factorized form. F of x equals to minus 1/3 x plus 2 x minus 1 squared. And given that g dash x is f of x and g0 is y, show that g is this quartic function. So from g dash to g, we are anti-differentiating. And what I'm trying to say is this is only 1 mark. You probably can use your CAS calculator to obtain the antiderivative, but don't forget to add c. So for example, I may say, okay, I just define f of x as minus 1 over 3 bracket x plus 2 times x minus 1 squared. And then I'll go for shift plus f of x dx. Just let you know this is getting you the general antiderivative, the particular antiderivative without plus c. So you still have to put c there. And to get this result, I suppose you should try to explicitly show what happens. Like if you expand this expression, you will just get the first 3 terms without add c. So you still need to show your determination of c, okay? I'll show you 2 methods. Method 1, g of x is the integral of f of x dx. That gives you, for example, minus x over 12 times x to the power 3, take away 6x plus 8, add c. And that is minus x to the power 4 over 12 plus x to the power 2 divided by 2 minus 2x over 3, add c, okay? So you need to show your general antiderivative with the c unknown and then go for g0 equals to 1. So you get a 0 plus 0 minus 0 at c equals to 1. Therefore, c equals to 1, and thus g of x equals to the given expression. Of course, this is just one possible approach. The other possible approach is you could use some advanced technique, but just be very careful. This is a show that question. So put a method 2 here. You might say g of x equals to the integral from 0, x equals to 0 to x. And then you say minus 1/3 bracket t plus 2 t minus 1 squared dt add, let's say g naught is 1. You can write a g naught here. And then you get some kind of a, antiderivative from 0 to x. And you say, okay, this is minus t to the power 4 divided by 12 plus t squared divided by 2 minus 2t over 3 add 1. So that leads to the desired answer, okay? And if you are using this method, you have to show a dummy variable in your definite integral and integration, okay? So this is method 2, okay? Dummy variable. And I find the values of x for which the graph g of x has a stationary point. So you say g dash of x equals to f of x equals to 0 because you want the derivative of g equal to 0, which is f of x. From here, you can see the factorized form gives you x equals to minus 2 and x equals to 1. Therefore, x equals to minus 2 or x equals to 1. Only these two values, okay? And I think it's a good idea to say, okay, define g of x equals to this bit at 1, okay? And then we can move on to the next part. If you look at the next part, I believe you probably also attempted this paper. The diagram below shows part of the graph y equals to gx, the tangent to the graph at x equals to 2, and a straight line perpendicular to the tangent at x equals to 2. The equation of the tangent at a point A with coordinate 2, g2 is y equals to 3 minus 4x over 3. The tangent cuts the y-axis is B, is here. The line perpendicular to the tangent cuts the y-axis at C. So probably you can annotate your graph in certain ways, okay? Well, you should do that because that facilitates your problem solving. So for example, I would say here, that is a 2g of 2 for this location. This is the tangent line. This is the normal line, okay? Normal means the line perpendicular to the tangent at the same point. We would like to find a b, so we can actually use, for example, y equals to menu, calculus, tangent line, g of x comma x equals to 2. So you get a 3 minus 4x over 3. As part of my working, I probably would say, okay, y, a, b, that is the tangent line, that is 3 minus 4x on 3. Therefore, the point B is 0, 3, okay? So that's all you need to write. And then find the equation of the line that passes through A and C, and hence find the coordinates of C. Well, you say, okay, YAC is the normal line. We don't have to do any algebra because we can use menu for A, normal line. Whenever you see this phrase, line perpendicular to the curve, you just use normal line command. So we say y equals to normal line, g of x comma x equals to 2. There we go. We have 3x over 4 minus 7 over 6. Okay, and then we want to find the coordinates of C, which is the y-intercept of this normal line. So you would have to, let's say, state the pair of coordinates. Therefore, C is 0 minus 7 over 6, okay? And you probably can annotate the diagram because for the first bit, the distance from O to B is the coordinate, y coordinate, that's 3 units. And the distance from O to C, well, it's below the x-axis. That's why it's negative 7 over 6. But once you get to, let's say, part 3 wants you to find the area of triangle ABC. So if you notice, this is just a simple geometric problem. You can identify this could be the base of the triangle. This is the perpendicular height because this is the horizontal direction. This is the vertical direction. And the horizontal distance here is just 2. So we can actually use the simple formula. For example, area triangle ABC equals to half times base, which is 3 plus 7 over 6. The distance is, this part add this part times 2, okay? And a 2.5 cancel, and you get a 25 over 6. That is the first method. Alternatively, you might want to say, okay, put an all here, area of the region. Like if you look at the diagram, it's the upper function subtracting the lower function, integrate throughout from 0 to the intersection 2. So we say area equals to from 0 to 2. The upper function is y AB of x minus y AC of x dx. And that should give you the same result, okay? So you can try your task calculator, for example, shift plus 0 to 2. And the upper function is this guy, subtracting the lower function. But if you write the explicit formula instead of the generic formula here, make sure you put a bracket in the second piece, because if you don't put a minus, you might make a sign error here, and the result will be slightly different and incorrect. So that will give you 25 over 6, okay? So that is the third part of part B, part B3. Let's move on. The tangent at D is parallel to tangent at A. It intersects a line passing through AC at E. You need to grab the key phrase. When I have a parallel tangent, then I'm trying to equate the gradients. So in order to find, let's say, point D, this is an x value that produces the same gradient. And there are 2 marks, so you expect some kind of, let's say, method mark or answer mark, etc., etc. What I'm trying to say is, first, your g dash of x should be, let's say, the same gradient. The same gradient, if you look at the previous working, that's minus 4 over 3, okay? So you say minus 4 over 3. But don't forget, you are trying to find the coordinates. You also need to find the y coordinate, okay? And the y coordinate is after you find the x value, you sub into y equals to g of x, and we solve simultaneously. Note that x in this case is not equal to 2. It's a different point at a D, okay? So what I'm trying to say is, okay, now you can solve for the coordinate pair D. Something here, okay? So I'm going to use menu 371, okay? Y equals to g of x. Notice that g dash derivative is f of x, so we say f of x equals to minus 4 over 3. If you press enter, you get a 2 pair of coordinates, but we don't want this bit because we just need this bit, okay? So the answer is minus 1, 25 over 12, okay? And lastly, if we want to find the distance A to E, well, here, I would like you to look for the tangent equation first, because you need to have, let's say, the tangent equation, okay? Tangent equation. And what I'm trying to say is you probably need to find one equation and this normal line equation, solve simultaneously for the point E, okay? So I'll go back, use the tangent line command, but this time because the point D has x value minus 1. So this is the new equation. So y dE equals to 3 on 4, take away 4x on 3, and y AC, that is something we obtained before. So you will see this is 3x over 4, take away 7 on 6, okay? And solve simultaneously, column 3, over 4. We have a point E somewhere, okay? So you can actually go for solve button. You may want to type in this manually. Y equals to 3x on 4. Take away 7 on 6. And y equals to, for example, this bit, comma x, comma y. And you should be able to get something along this line. 23 over 25 and minus 143 divided by 300. A slightly larger number. And then the point A, we don't know the exact y value, but we can also say this is 2g of 2, okay? We can leave that because that is not my final item we want to find. So we say also point E, point A is 2 comma g of 2. So the distance of AE is just, Pythagoras, okay? It's a Pythagoras. Therefore, I'm saying, okay, x2 minus x1 squared and y2 minus y1 squared. We say 2 minus 23 over 25 bracket square plus g of 2 subtracting negative 143 divided by 300 squared, okay? And then we can just calculate the answer. If I were using, let's say, the standard approach, like just a usual math method approach, I have to type everything out and make sure all the brackets are correctly entered in the CAS calculator commands, okay? So the answer is 27 over 20, which I believe is correct. Don't have to put units, but just put units anyway. Alternatively, another shortcut, if you take specialist math, you might want to use, let's say, some square bracket, 2 comma g of 2, subtracting another square bracket, like a matrix, 23 over 25, comma, minus 143 divided by 300. And then you use the command norm of the difference between 2 points. That will also give you 27 over 20, okay? So that is the end of this question. I think there's another approach, but I don't think it's awfully apparent to most of the students, like you might know the distance between 2 parallel lines. Well, I'm sorry, apologies for being overboard, but I'm also thinking about some specialist math approach. Like you might want to get, let's say, a perpendicular vector. This is a perpendicular vector, and just find, let's say, some sort of perpendicular resolute or scalar resolute, etc., etc. But this is just math method, so don't go overboard, okay? Stay with the bread and butter method. Let's move on to the next page. Okay, question 3. It's a relatively long probability question. I'm just diving into the question itself. You have a class of 22 new laptops. The probability that a student does not correctly plug the laptop into the trolley at the end of the lesson is 10%. Well, it's now almost 10 years. Imagine a situation at your school. You have a trolley. This is a wheel, this is a wheel, this is a wheel. You might have some locker here. And this one is plugged into a power port. And this one is a charging trolley. You might slot in an iPad here, 1 iPad, 2 iPad, 3 iPad, etc., etc. So if you correctly plug in the electronic device, the trolley will be charging the device. But if you plug it in the wrong way, well, not only it harms the device, but also it does not charge it up. So therefore, it has a likelihood of 10%. So this is like the probability of success. Well, it's not any kind of success, but anyway, determine the probability that at least one of the laptop is not correctly plugged into the trolley at the end of the lesson. Give your answer correctly for decimal places. So it's either correctly plugged in or incorrectly plugged in. I would say, okay, if I say this is what kind of okay, I'll say this is a laptop correctly plugged in or not. How many laptop correctly plugged in or incorrectly plugged in? Binomial n equals to 22, p equals to 0.1. I probably would specify, okay, number of laptops not correctly plugged in. Okay, and then we want this L at least 1. So we would like to find the probability of L greater than or equal to 1. You might want to use 1 minus probability L equals to 0, but because you have a binom CDF, well, you are not encouraged to write the CAS calculator syntax on your paper. But anyway, I'll just use the calculator syntax here. Binom CDF 22.1 from 1 to 22. So the answer is, well, I can't just jump into the answer. So I say this is 22, 0.1, 1 to 22. And that gives you 0.9015, 229, dot, and it's rounded to 0.9015. Okay, there is a proper mathematical notation if you don't want to write this binomial CDF command. I'll just write that in pencil, okay? It's using the summation notation, which is not a requirement in mathematical course. Summation notation from x equals to 1 to 22. 22, choose x, 0.1 to the power x, and 0.9 to the power 22 minus x, something along this line, okay? But it's not a requirement in mathematical course. Okay, a teacher observes that at least one of the returned laptops is not correctly plugged into the trolley. Given this, this is a conditional probability with binomial distribution. So we would like to get a probability some event, but you put the given that L is greater than or equal to 1. Under these conditions, find the probability that fewer than 5. Fewer means strictly less than, no equal sign. So you say L is less than 5, okay? You need to recognize the binomial distribution here. And then you take the intersection between these two events, less than 5 for a discrete variable. L less than 5, in this case, is L less than or equal to 4, okay? So we want L greater than or equal to 1, but less than or equal to 4. That is my numerator probability. I probably need to write it properly. So it's 1 less than or equal to L less than or equal to 4, okay? And then we say divided by probability of L greater than or equal to 1, all right? And it's a good idea to, let's say, set out the substitution. But if you know the division of two binomial distribution, binomial CDF command, you can just get to the answer. This is my personal habit, okay? So I might say, okay, from 1 to 4, that is 0.839389 something, because this question also wants 4 decimal places accuracy. You have to use all possible digits to avoid any rounding error. This is very similar to chemistry or, let's say, physics, if you have a multi-stage question. So you can see I quoted all digits here and I press Control Enter. So the probability is eventually 0.9311, okay? 9311, because you need to round this 7 up. I'll put the unrounded value here for your reference. 0.931079, ... The top number, you don't have to copy down everything. You just copy a few more digits like 0.839389. The rest represented by dot, dot, dot. And this bit is 0.9015,229, dot, 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 etc., etc. So show your conditional statement and how it should be further expressed into a division of two statements, and then substitute the values and get the answer. Okay. All right. The time for which a laptop will work without recharging the battery life is normally distributed with a mean of 3 hours and 10 minutes and a standard deviation of 6 minutes. So you can see here it's in hours and minutes, but 1 hour is not 100 minutes, it's 60 minutes. Therefore, you better use consistent units for these two quantities, okay? Consistent units. And suppose that laptops remain out of the recharging trolley for 3 hours, etc., etc. For any one laptop, find the probability that it will stop working by the end of these 3 hours. So let's say let X be a normal distribution. 3 hours is 180 plus 10, that's 190 minutes. That's the mean value. And the standard deviation is 6, so the variance is 36 or 6 squared. Battery life in minutes. Okay. And by the end of the 3 hours means the battery life is less than 180. So we would like to find a probability of X less than 180. And you might want to use norm CDF. This is a continuous random variable now. Norm CDF minus infinity to 180. The mean value is 190 and the standard deviation is 6. And for those of you using ClassPad, it's the other way around, okay? They want you to fill out the standard deviation first, then the mean value. And I'm going to use the norm CDF. Menu 552 minus infinity, 180, 190, 6. So the answer will be 0.04779, 0, dot, 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 rounded to 4 decimal places, so 0.0478 4 decimal places. Okay. Okay. A supplier of laptops decides to take a sample of 100 new laptops from a number of different schools. The sample size of size 100 from the population of laptops with the mean battery life of these 3 hours and 10 minutes and a standard deviation of 6 minutes. P hat is a random variable of the distribution of sample proportions of laptops with a battery life of less than 3 hours. Okay, so if one laptop, let's say, has a probability of battery life less than 180 minutes, this probability is 0.047790. Then I've got 100. So for such 100 independent laptops with 100 independent lifetimes, you need to use a binomial. This is a switch. This part is a switch from one binomial to 100. Actually, I should say Bernoulli, okay? Bernoulli sequence, Bernoulli random variable. So what I'm saying is, okay, let's say let Y be a binomial distribution, n equals to 100, p equals to 0.047790, etc., etc. So that random variable has a different meaning. Whether or not one laptop is, has a lifetime less than 180 minutes or greater than or equal to 180 minutes. So it's yes or no type. 0, 1, yes or no, big, small, etc., etc. So for each individual variable, it's like a Bernoulli. And then add up 100, you get let's say a binomial random variable. And then the p hat has the meaning. P hat has the meaning of Y divided by 100. So that is a sample proportion. Therefore, the probability statement, if you multiply p hat greater than or equal to 0.06 by 100, you get, let's say, Y greater than or equal to 6. and then y is greater than or equal to 5. So this is another conversion. And you should be able to get, let's say, 6 less than or equal to y less than or equal to 100 divided by probability of 5 less than or equal to y less than or equal to 100. And then you just get the answer, okay? So in this case, I'm going to use a binom CDF again, but this time I should use 100 for the sample size and the previous value. Try to quote more digits. And from 6 to 100, that's the numerator. And then the denominator is going to be this one. And I just divide them through. Okay. So the top number is 0.344338, etc. divided by 0.5234068. And it's rounded to 0.659, okay? 0.65878 actually. Should I say 8? 0.065. Actually, this is an 8. I'll fix that. I shouldn't use my whiteout. This is an 8 here. 7, 8, 7, 9, etc., etc. Okay, so that is the final answer, correct to 3 decimal places. Okay, well, it is known that when laptops have been used regularly in the school for 6 months, their battery life is still normally distributed, but the mean battery life drops to 3 hours. It is also known that only 12% of such laptops work for more than 3 hours and 10 minutes. Find a standard deviation for the normal distribution that applies to the battery life of laptops that have been used regularly in the school for 6 months, correct to 4 decimal places. So this is another normal distribution for the lifetime of each individual laptop. The mean value drops to 3 hours, so 180, and standard deviation is unknown, so I put a sigma squared here. And if I draw a curve, let's say, the new mean value is 180, that's x2. Only 12% of such laptops work for more than 3 hours and 10 minutes. So that is 190. And this probability is 0.12. So therefore, the opposite side will be 0.88. What I'm trying to do is I'll get, let's say, a z-score, okay? Z-score 0.88 equals to 1.174986, something along this line. And according to the conversion between a general normal and a standard normal, this number 190 here can be converted to this z-score by using the formula z equals to 190 minus the mean value, 180, divided by sigma, okay? So once I equated these two, I'm able to find a sigma. So for example, I can solve inverse norm 0.88. 190 minus 180 divided by sigma, for sigma. Correct to 4 decimal places, that is 8.5107. If I'm not mistaken, that's in minutes. Okay, better specify. Okay, find a standard deviation for the normal distribution. You need to specify the unit because the question does not have the question stamp does not specify the unit, and the units are inconsistent, hours, minutes, or minutes, etc., etc. Okay. Alternatively, you might want to use you might want to work with hours, etc., etc. Hours only. So if you are working with hours only, that is like 3 plus 3 hours 10 minutes. That's 3 and 1/6 hour minus 3. then this answer will be in terms of hour, okay? Like a 0.1418, etc. So that's the nuance of this question. But also some students may use this command like a norm CDF. Let's say 190 to infinity. 180 is the new mean, and S or X is the unknown standard deviation, equals to 0.12, solving for X. If that's the case, it doesn't solve. But if you specify, let's say X is a standard deviation greater than 0, you can also figure that out, okay? So this is another numerical method. I'll put it here. Or norm CDF. Let's put with the pencil. Norm CDF 190 to infinity, 180 for sigma equals to 0.12. Solve numerically. Sigma equals to 8.5107 minutes. And all in hours. Sigma equals to 0.1418 hours. Okay, that's very rare. Like a mu equals to 3, and the x2 value equals to 3 and 1/6, etc., etc. Okay, right. Let's move on. Okay. The laptop supplier collects a sample of 100 laptops that have been used for 6 months from a number of different schools and tests their battery life. Laptop suppliers wishes to estimate the proportion of such laptops with a battery life of less than 3 hours. Notice they have been used for 6 months, so probability of, let's say, x2 is less than 180. That is a half, okay? Because for each laptop, half, okay? 0.5. And find the probability that a first laptop found to have a battery life of less than 3 hours is the third one. So it's like the first one is like x2 is greater than or equal to 180. X2 is greater than or equal to 180, and x2 is less than 180. So in such a sequence, we sample, let's say we test one laptop at a time. We need to test 1, 2, 3 laptops. The first 2 laptops will have the lifetime greater than or equal to 180 minutes, but the third one is the one with the lifetime less than 3 hours. So this is like, if you draw a tree diagram, this is like A, B, C, okay? A, B, C, half, half, half. Eventually, you get a half to the power of 3. That is 1/8, or 0.125, okay? So this is actually, some kind of tree diagram problem for independent events, subsequent events. The laptop supplier finds that in a particular sample of 100 laptops, 6 of them have a battery life of less than 3 hours. Okay. Now we want to determine the 95% confidence interval for the supplier's estimate of the proportion of interest. Give values correct to 2 decimal places. This is a classic, calculator problem. So we have n equals to 100, x equals to 6, like a number of interest. And C level is 0.95. So I can just press the calculator buttons to get the confidence interval. This is the confidence interval for population proportion. So we say menu 6, 6, 5. And we just need to type a 6, 100, press OK. Make sure you double check your confidence level. Sometimes the other question says 0.98. Sometimes the question says 0.90 or 90%. Sometimes it's 0.99, okay? And we can just get a confidence interval. CI is approximately 0.01345 dot, 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 and 0.1065 6, etc. So it's rounded to 0.01, 0.11. Okay. So rounded to 2 decimal places, and it's a round bracket according to the VCAA formula sheet. Okay. All right, last part. If you look at the 2016 exam reports, the question did have a little bit problem. Like if you integrate the function from 0 to 210, it doesn't give you exactly 1. So this is called exponential distribution, or actually I should say it's some kind of special gamma distribution or Erlang distribution. Anyway, these things lower bound here should be minus infinity, but they truncated the small bits from minus infinity to 0. That's why when you integrate this function from 0 to 210, it doesn't give you exactly 1. But you can only play with the cards you have in your hand. So if you want to find the mean battery life, this is just finding, let's say, 0 to 210, x times f of x dx, okay? And notice that this phrase median, the median here is no longer an explicit part of the current study design. So an alternative way they could assess this is like find the 50th percentile, okay? And that is still a valid way of saying, okay, find the median, okay? We usually say this is m. So that is the probability under the curve from 0 to m, f of x dx equals to 50%, which is 0.5. And then you solve this equation numerically, like m is between 0 and 210, okay? So I outlined the solutions here. Well, you could have defined f of x, which is 210 minus x, close bracket, times e to the power of fraction, x minus 210 divided by 20, all over 400. And if you press shift plus, that's 0 to 210, x times f of x dx. And that gives you 170. 170.00688, etc., etc. So it's rounded to 170.01 minutes. But I believe VCAA in that year, they specified in the assessment report, if your answer can be rounded to 170, correct to the nearest whole number, this mark was paid. Like if you get a 170.01, that's fine, etc., etc. And for this part, still you need to integrate the function rather than x times f of x. So if you solve the integral without the x equals to half, comma m, and you need to change the upper limit to m. Given that 0 less than m less than 210, you get a 176.45, okay? Again, if you do the other way, your answer is slightly different, like a 433, okay? And I probably need to enlarge the screen here. Let's zoom out, zoom in a little bit, make the screen larger. So what I'm trying to say is, if you look at this distribution here, in fact, if it's from minus infinity to 210, f of x dx, that is 1, okay? If it's from 0 to 210, you can see this is not exactly 1, right? Actually, it has, let's say, some exact values, okay? So the actual mean value, if the question was correctly defined on a suitable domain, is 170. And if you were to find the m value, I need to delete the x here. equals to half M. And you have to solve some kind of, transcendental equation. This can only be solved by a special function called lambda omega function or product log function, etc., etc. And you don't actually get, for example, some kind of thing. So the actual correct answer should be 176.43 if the domain was from -infinity to 110, okay? Anyway, that's my discussion to this question. And then let's move on and look at the last part. My CAS calculator screen here. Don't need that much. 2. The last question, extended response question on this paper was a long extended response question with multiple parts, multiple sheets. Part A wants you to express this rational function in a standard rectangular hyperbola form, 2 marks. Part B follows part A, uses the same function and ask you to find the inverse domain and rule. And then they give you a diagram. And this is the shaded area. You want the shaded area between the line y equals to x and f of x. That's 1 mark. And part 3, subpart 3, we want to find, let's say, the shaded area between f inverse and f. And they can tell, you can just double up the previous answer by symmetry to get the shaded area here, okay? So let's get this down. First of all, you can do this one by hand easily, like 2x plus 1. If I plus a 4 here divided by x plus 2, I'll get exactly a 2. But then I need to, let's say, subtract a 3 divided by x plus 2 to recover the plus 1 here. So you actually get a 2 minus 3 divided by x plus 2, where a is 2, b is -3, okay? You might want to write it like this, 2 plus -3 divided by x plus 2, something along this line. Of course, you could use your CAS calculator, say control up, and you can define the function anyway. So say f of x is assigned to 2x plus 1, x plus 2, and then expand f of x, comma x. Yep, exactly the same thing. Next part, find the rule and the domain. So we can solve x equals to fy, comma y. And you get something like that. Don't forget, you need to use f inverse to specify the rule. And the domain is just x not equal to 2, okay? Because this one had a domain, original function's domain is r backslash -2. And the y value should be excluding 2. So the range of the original is the domain of the inverse. So we say f inverse of x equals to, or you might want to say minus bracket 2x minus 1 divided by x minus 2. Or f inverse of x is 1 minus 2x divided by x minus 2. Or in the expanded form. You don't have to write everything down. I'm just listing all possible equivalent answers here for your reference, okay? You might get a -3 over x minus 2, take 2. But that is just for 1 mark. You also need to specify the domain. Say domain f inverse is r backslash 2, okay? Or you might want to say -infinity, x belongs to -infinity to 2. Union 2 to infinity, 2 is excluded. It's not good enough to say x not equal to 2, okay? Because you're just excluding one value from what? So don't use, just an inequality. You have to specify the full number set, okay? Find the area of the shaded region. So if you solve x equals to f of x comma x, you get a minus 1 to 1. And then you can just integrate from minus 1 to 1, f of x minus x dx. So that is the final answer, 4 minus 3 log 3, okay? So we say area equals to minus 1 to 1, and f of x, take away x dx. So the area equals to 4, take away 3, log E3, okay? You can write 3 ln 3, but make sure you put a bracket here. Or let's say, you might say 4 minus log E27. You don't want to go overboard. Just carefully enter the equation and write down one version of the correct answer. That's it, okay? Or some student might say, okay, log e to the power 4 divided by 27, etc., etc. But it has to be correct anyway. This part, as I explained, by symmetry, area equals to 2 times part B2, okay? So that is 8 minus 6 log E of 3, okay? So that is the final answer, or other equivalent forms. All right, move on. Part C, 3 marks. Part of the graph of f is shown in the diagram below, so we're discussing the part where x is greater than minus 2. There is a point CD on the graph of f. Find the exact values of CD such that the distance of this point to the origin is a minimum, and find this minimum distance. So I'm going to outline a few different methods. Method 1. You will have to, let's say, point C comma D equals to C comma f of C. So the distance between distance, let's say OP, let distance OP equals to L as a function of C, which is the square root of C squared plus f of C whole thing squared. Okay? We form a distance function L of C and use, for example, L dash C equals to 0 or F minimum. And you can see the closest distance can only occur between minus half and 0. So the domain restriction is minus half to 0. C belongs to. And then you find the C value. Then you can find the D value. And then don't forget to find the minimum distance. So the minimum distance is L something, and it gives you some particular distance, okay? I'm going to say L of C is assigned to square root C squared plus bracket FC bracket square. And F minimum, LC, comma C, minus half, 0. That will be root 3 minus 2. And the D value is F of this value, like the Y, 2 minus root 3. And L of this expression is 2 root 2 minus root 6, okay? Root 3 minus 2, 2 minus root 3. So P is like root 3 minus 2, 2 minus root 3. And root 3 minus 2. And this is 2 square root 2 minus root 6. Another thing I want to mention here, I primarily use TIS buyer, but occasionally I use ClassPad. If you are using ClassPad to tackle this problem, what you might end up with, let me just show you. You will get an equivalent answer to this one, okay? So let me clear everything. I'll define f of x equals to 2x plus 1, x plus 2, and define distance of x equals to some kind of square root x squared plus f of x whole squared. And if I take the derivative, d of x, solve equal to 0, about solve. Okay, you get these two values, but only this value will lie within, let's say, the domain restriction. Otherwise, this one will give you, let's say, you have to knock out this one, okay? Only this root 3 minus 2. Solving, you should get a similar answer. Yeah, you can see this is a slightly different expression. You have to press simplify to get that, okay? And the other thing is, if you go for the shortest distance, the minimum distance, you get something like this. This is equivalent to 2 root 2 minus root 6. Well, if you get a perfect square under a square root, it's just because some kind of different algorithm between two calculators, okay? Anyway, so that is this one. I forgot to mention method 2. Method 2 is like, okay, you might get, let's say, a tangent line at this point. And you may also get a line between origin and the point P. And if it's the closest point to the origin, then these two lines will be perpendicular. So another method is, I'll specify it here, method 2 here. Use perpendicular gradient. But then you still need to find, let's say, the D value, and then find the shortest distance, etc., etc. Say, for example, f dash c times fc minus 0 divided by c minus 0 equals to minus 1, something along this line. And then d equals to f of c. You get that, and then solve to find that, and then still find the distance using Pythagoras, okay? Anyway, so that's all I need to say for this question part. This one lost many students if you read through the assessment report. So I think the key point is to get, okay, this is a function g of x is kx plus 1 divided by x plus k. Show that x1 less than x2 implies gx1 is less than gx2, where x1 and x2 belongs to, let's say, the domain restriction here, and this k value is greater than 1. What I'm trying to say is, this means if you look at the part of the graph, your x1, gx1 might be here. Your x2, gx2 might be here. So you want to pick any x1, x2, where x2 is larger than x1 to show the second y value is always greater than the first y value. And this implies the function is strictly increasing, okay? Want to show that g of x is strictly increasing for the given condition. You have multiple methods, but definitely you need to use, let's say, suitable algebraic approach, not just like pick x equals to 1, x equals to 2, or x equals to some certain values. You have to argue from the x1, x2. Okay, so I'll define g of x as k times x plus 1 divided by x plus k. And use the expand button, g of x. So you actually see this is a valid form. I probably need to draw your attention to this one. For example, I may say, okay, method 1. G of x equals to k plus 1 minus k squared divided by x plus k, okay? And we might say, okay, if x1 is less than x2, then x1 plus k is less than x2 plus k, okay? And both of them are, positive quantities. As x1 plus k greater than 0, x2 plus k is greater than 0, the reciprocal will be the other way around, okay? The reciprocal will be the other way around. We say 1 divided by x1 plus k. And we say is greater than 1 over x2 plus k. The next thing, how do I twist that the other way around? Because I want the term with x2 to be greater than the term with x1. Note that k is greater than 1. So k squared is greater than 1. Therefore, 1 minus k squared is actually less than 0, okay? So if you multiply both terms by 1 minus k, multiply both sides by 1 minus k squared. We then have 1 minus k squared divided by x1 plus k is actually less than 1 minus k squared divided by x2 plus k. Okay? Then, if you add k to both sides, which recover this form, you will get, let's say, k plus 1 minus k squared divided by x1 plus k is less than k plus 1 minus k squared, x2 plus k. So, g of x1 is less than g of x2, right? So this is, the approach or the proof from first principle, and you can see there are multi-layers you need to consider. And to be honest with you, I think this part is the hardest part on this paper. Okay, this is a kernel. This is ice on top of the cake in 2016 exam question. But if I want to get my life easier, here is another approach. To prove this function is strictly increasing, we can use the derivative. We simply find the derivative. And you can see this expression is much simpler than the previous expressions we dealt with. And to argue this thing is strictly increasing, we say, okay, as k is greater than 1, k squared minus 1 is greater than 0. And x is greater than minus k. Then x plus k bracket square is strictly greater than 0. Therefore, g dash of x must be always positive. And it implies g of x is strictly increasing on x belongs to minus k to infinity. Therefore, we can argue that, okay, if x1 less than x2, then any gx1 must be less than gx2, okay? So that is the description from first principle, the strictly increasing bit, okay? I think the most popular method will lie within these two kinds, okay? Within these two kinds. So I would stick to the calculus method, okay? Calculus method. Anyway, hopefully that helps. The last few parts are just, very long. Let x be the point of intersection of the graphs gx and y equals to minus x. Find the coordinates of x in terms of k. So remember, your function only has one branch in this case, okay? Your function only has one branch. For example, this is y equals to k, and this is x equals to minus k, and you sort of get something like that, okay? And if you just find the intersection between them, there's only one intersection. And find the value of k for which the coordinates of x are minus half and a half. So, right. If I have solve button, g of x equals to minus x comma x. You get two expressions, but the problem is this is a negative root minus k. This is a positive root minus k. Which one am I going to choose? I believe you are going to choose the second one, because if you choose the other one, it's to the left side of x equals to minus k. You have to only choose this one. And the coordinates of x, you have to state, let's say, okay, y equals to minus x. So you get, let's say, this expression the other way. So we say the other way around. We say g of x equals to minus x and y equals to minus x. Note, x is greater than minus k, okay? Therefore, the coordinate x will be square root k squared minus 1 minus k minus square root of k squared minus 1, etc. Okay? So that's a pair of coordinates we want, okay? And find the value of k for which the coordinates of x is minus half and a half. You can just sub in, let's say, minus half and a half into the expression. So solve g of minus half equals to half. Okay. You get k equals to 5/4, okay? And the problem solved, okay? Otherwise, you are going to manually equate these to a minus half and this one to half. Well, eventually it's the same equation. So you get a k value 5/4, okay? But I just noticed if you equate this bit to minus half, okay? Yep, only one solution. Okay, let ZYX be the vertices of the triangle XYZ. Let SK be the square of the area of triangle XYZ. Find the values of K such that SK is greater than or equal to 1. Note that K must be greater than 1, okay? Which was specified together with the definition G of X, okay? What I'm trying to say is I'll figure out, let's say, distance OX, because this is minus x, is perpendicular to zy. And you can see this is minus 1, and this is 1, 1, okay? So you might want to use some kind of, Pythagoras, okay? For example, this side is 2, this side is 2, this is 2 square root of 2, okay? So distance zy equals to 2 square root of 2, okay? So that is the base of the triangle. Now I want to figure out OX. Distance OX equals to square root of something square plus something square, okay? So it's k squared minus 1. And if I look at, let's say, the expression, minus k minus square root of k squared minus 1, okay? To get that expression, you don't have to simplify this one. All we want is like a SK, the square of the area. So the area of triangle XYZ equals to half times distance ZY times distance OX. Then I just square everything to get this S of K, all right? Let's do it. So first of all, if I get, let's say, square root of something squared plus something squared, this expression, same expression, but I think this is a plus, this is a minus. Eventually you'll see it's just 2 lots of the first term squared. You get something like that. Then we multiply that by half times that times 2 square root of 2. I get that. And then we square everything. So that is my S of K. Okay, I would like to solve S of K is greater than or equal to 1, comma K. Notice that K is greater than 1. you get this domain restriction. If you don't put let's say k is greater than 1, you most likely get 2 sets of values, but you don't want to, include the 1 here. So you have to, let's say, get a correct expression. All right, S of k is 4 lots of square root of k squared minus 1 minus k, whole thing squared, okay? We say solve sk greater than or equal to 1 for k. Eventually, k is larger than 1, but less than or equal to 5/4. So that is the number set we want. Okay, finally, towards the end of the paper. The graph of G and the line enclose a region of the plane. The region is shown shaded in the diagram below. Let AK be the rule of the function A that gives the area of the enclosed region. The domain of A is 1 to infinity. 1, give the rule for A of K. 2, show that A of K is between 0 and 2 for all K greater than 1. This one, A of K is actually the upper function minus lower function. We know this intersection is x equals to -1. This intersection is x equals to 1. So A of K equals to the integral from -1 to 1. And we have G of x subtracting x dx. We can say shift plus. Actually, I can say I can get an expression first. -1 to 1, G of x minus x dx. So you will see this expression, but notice that you don't have to put absolute values because k is greater than 1. You can get rid of the absolute values. Therefore, A of k is k squared minus 1 times log e bracket 1 minus k, 1 plus k, plus 2k. And the next thing is we want to show that 0 is well, 0 is less than k less than 2 for all k greater than 1. I think in the exam report they used some kind of limit notation to talk about, okay, this shaded area should be bounded by a triangle, a right angle isosceles triangle like this. So you argue, okay, it never exceeds these two boundaries. That's why it's always less than 2, because the area of the isosceles right angle triangle is 2. And then the k approaches to, let's say, 1, then everything will be, everything will be approaching to 0, something like that, okay? What I want to say is, true, you could argue from that aspect, but another possibility is if you sketch the graph. If you sketch this graph here, you actually see, okay, this is how the graph looks like. And it has some kind of, twist here. And the domain is from, let's say, 1 to infinity. And therefore, you could say, okay, it goes from here to here. So one possibility I would answer this question is, okay, let's say, this is A of k, this is 0, this is 1, this is k. So I sort of get something like that, okay, something like that. And this is 1, 2. We say when k is approaching to 1 plus on the right side, area of k is approaching to 2. When k is approaching to infinity, positive infinity, A of k is approaching to 0. And A of k is strictly decreasing and continuous over k belongs to 1 to infinity. Therefore, the range of this function must be 0 to 2.